Hello everybody, so the next topic is linear approximations. The idea is that we want to know how to approximate, for example, square root of 4.3 or 4.3 approximately equal to 1. Of course we can just put it into a calculator and find pretty good approximation, but still it's a good idea to know like exactly how a calculator works and how a calculator calculates those approximations. Now one approximation could be very straightforward because 4.3 is approximately equal to 4. Let's call it idea number 1 if you wish. Idea number 1 is that since 4.3 is approximately equal to 4, so square root of 4.3 is approximately equal to square root of 4, which is 2. So the first approximation is 2. Or actually I can tell that the actual result must be slightly bigger than 2 because 4.3 is slightly bigger than 4 and the square root is an increasing function. Therefore square root of 4.3 should be slightly bigger than square root of 4, which is 2. But how much bigger? So let me write it. So since 4.3 is greater than 4 and square root of x increasing function, so square root of 4.3 is definitely greater than square root of 4, which is 2. So we can tell that this number is slightly bigger. But how much bigger? So here's how we can determine this. Here is the next idea number 2. Idea number 2 goes that the graph of a function is close to the tangent line, or backwards tangent line to a graph is close to the graph itself. So it's actually easy to see geometrical on the picture. So if you have a graph of a function, let's say x, y, and here is graph of a certain function, let's say y equals f of x, and then we have some point on this graph. Let's say this point has coordinates a, f of a, because if the x coordinate of this point is a, then the y coordinate, since it lies on the graph, the y coordinate should be f of a. And now let's draw the tangent line. The equation of tangent line, again I remind you, the equation of the tangent line can be calculated as point slope equation. So equation of tangent line is point slope equation, which is y equals y1 plus m times x minus x1. But in this specific situation, x1 is a, this is x1, this is y1. x1 is a, y1 is f of a, and the slope is the slope of the tangent line, which is the derivative. So slope is derivative, which is f prime of a. So this is what goes for m. So once again, y equals, for y1 we have f of a, plus for m we have f prime of a times, and x minus, and for x1 we have just a. So this is the equation of the tangent line. Once again, equation of the tangent line is this: y equals f of a plus f prime of a times x minus a. And the equation of the graph is this, y equals f of x. And as you can see on the picture, near the tangency point, near this point, the tangent line is so close to the graph that it's actually difficult to tell them apart. Only for, like up to here, they go almost along with each other. Only further down they go apart. Same thing on this side. Like some distance they go together and only then they go apart. So bottom line is that graph y equals f of x is close to the tangent line. So let me write it here. Graph y equals f of x is close to tangent line y equals this. Y equals f of a plus f prime of a times x minus a. So this is close to that. And since they are close, that means their y coordinates must be close. And that means f of x is approximately equal. Y coordinate of the graph is just f of x. Y coordinate of the tangent line is this. So it's approximately equal f of a plus f prime of a times x minus a. And this equation is actually the linear approximation. So it basically tells you how to approximately calculate function value. And here are some examples. Let's go the same example, square root of 4.3. Square root of 4.3, we want to approximate more precisely than just saying that it's approximately equal to 2. So how can we do it more precisely? So we can use this formula. Exactly how do we use it? This number inside the expression 4.3 will be my x. So x value is 4.3. And the function should be the function that applies to this x. In this case it's a square root, therefore f of x should be square root of x. Now we need to decide upon a. What is a? A is supposed to be a number for which it's easy to calculate both the function and the derivative. So a should be a nice number. A should be a nice number. And besides, this nice number should be close to x. Remember that the tangent line is close to the graph of the function, only nearby. Further away it becomes further apart. So we want x to be close to a. So a should be a nice number close to x. Typically, nice number is actually an integer, and the integer close to x is just 4, and square root of 4 is also something that is easy to calculate, so that's precisely what we need. So make a equal 4. So once again, x is basically taken right from the given expression, and a is not given, but we just choose it as a nice number close to that. So now we have everything here, and we just plug in. We need to calculate all the portions, all the parts of this formula. So what is f of a? Well, f of since f of x is square root of x, therefore f of a is square root of a, and since we have chosen a to be 4, so it's square root of 4, which is 2. So that's my f of a. Now, f prime of x, in order to calculate f prime of a, first we need f prime of x. So I remind you that f of x is x square root of x. F prime of x is therefore 1 over 2 square root of x. That's the derivative of square root of x. And therefore f prime of a, since a is 2, since a is 4, f prime of a is 1 over 2 times square root of 4. And obviously just 1/4. 1 over 2 times 2 is 1/4. So this is my f prime of a. So I have determined f of a, which happens to be 2. I have determined f prime of a, which happens to be 1/4. And And now we pretty much have everything, and A itself is already, we have determined it's a 4. So we basically have determined everything, and f of x is square root of x, but since x is 4.3, so f of x is square root of 4.3. It's precisely the given expression. So just putting it all together, we get square root of 4.3 is approximately equal. Now f of a is 2 plus f prime of a is 1/4 times, open parenthesis, x value is 4.3 minus, and here we have a, which is just 4. Now this calculation is so simple that we can't even do it in our head or using calculator if we wish. So what is it? It's a 2 plus 1/4 times, and 4.3 minus 4 is just 0.3. So 1/4 times 0.3 is 2 plus 0.075. I think it's 3/4, only 1/10 of 3/4, and therefore it's 2.075. Indeed, it was slightly larger than 2, but now we have much better approximation than just 2 itself. Now, to double check, indeed, we can actually calculate it on the calculator. To double check this calculation, we can just punch in square root of 2 and square root of 4.3 and see what the calculator does. Square root 4.3. So what the calculator is doing is it's saying that, so on calculator, square root of 4.3 is 2.0736441, which is pretty close. So once again, this method is called linear approximation.